Here we have a sample problem. A positive electric charge Q is distributed uniformly along a line of length 2a lying along the axis between y equals negative a and y equals positive a as shown in the figure. Find the electric potential at point P on the x-axis at a distance x from the origin. Here we take a small segment dq of the rod and determine the electric potential at point P by the segment. We see that the distance r is just the Pythagorean equation, and we notice that as we evaluate the charged rod the distance r changes. Examining the equation for r, we see that the distance x along the horizontal remains and only the y distance changes. So we define the small segment charge dq. We write an expression for it as shown here in equation 15. For charged wires dq is given as a function of the linear charge density wavelength, so we write it as equation A. Here the linear charge density is just the total charge over the total length of the wire, which is twice of A. Substituting this to the general expression for electric potential shown in equation 14, we get an expression for the voltage for the system as shown here I equation B. Here we have to use mathematical identities to solve for this integral function. So we isolate the integral function of equation B. We let y as a function of tangent theta, and this in turn turns dy to a function of x times the squared secant theta. So we continue to manipulate the function further and we arrive to much simplified function of the integral as function of secant as shown in equation C. The integral of a secant of theta can be expressed as one of its trigonometric identities as shown by equation D. We then manipulate the equation and arrive at the function d, which we will evaluate from a to negative a. We evaluate the function d and get an expression of the difference of log functions, and we simplify it as equation A. We then substitute this back to the equation for the electric potential in equation B. So the expression for the electric potential for a straight rod with varying length r is shown in equation F.